The Art of Illusion 3D modeling software gets a lot of bad press around the RepRap group from people who are used to using things like AutoCAD and such not. I started writing CAD software in the 1960s and stopped writing CAD software sometimes in the mid-1990s. I've used a lot of different packages as well. Art of Illusion has its limitations, there's no question about it, but it is quite a useful package if you can just get past your prejudices and use the darn thing. Now, what I'd like to go through with you this evening is how you build an object in Art of Illusion for printing and how that differs from building an object for milling. First off, I would like to, for this exercise, make a involute profile gear, 12-toothed, and I would like that gear to be centered around a 3/8 inch hexagonal nut. Now, why I want to do this is I want to make a linear stepper motor out of a ordinary cheap tin can stepper. The reason for that is that you can buy linear stepper motors that are built around their own thrust collar, which is nothing more than a nut, that will run up and down a threaded rod. These typically are pretty expensive. The ones I'm using cost about $65 to $70 a piece just for the stepper motor. The threaded rod costs more. Now, you can buy a tin can stepper motor of the same power and speed that has a shaft instead of being designed to fit around a threaded rod for about $7. So what I'm after is to design a set of parts that allows you to use one of those cheap tin can stepper motors to achieve the same effect as a linear stepper motor and its thrust rod that costs upwards of about $90 to $100. Okay, let's start. Now I'm not going to go through every step, but I'm going to give you an idea of what's going on. First off, you go to your scripts, you select an experimental profile gear script, and I'm not going to take you through that because it takes a little while to do all of that. Once you've gone through that script, though, you can get something that looks like this. Now, our grid is on a centimeter scale with gradations of half a centimeter. So what you're looking at is a gear here which is roughly, what would you say, about has a radius of about 1.8 centimeters. Now, once you've done that, all you have to do is extrude it. There it is, using the extrude function, and then you get a, let's see, show this, oops, pardon me, wrong one. You get a 12-toothed gear. Okay, and let's hide the original. Now, it still looks like it because you've extruded it toward you. Now, if you click and turn it a little bit, you can see there's your gear. Very sweet looking. Now, what you want to do then, let's go ahead and hide that now. Then you want to develop an outline for the nut. Now, there's another script that you can go and get that allows you to develop polygons, and we won't go through that one because it's just not all that important right now. So let's go get our polygon. Let's show it. Okay, now that is the size of a hexagonal nut that will screw onto a 3/8 inch threaded rod. Okay, now let's go ahead and extrude that one, and we will get a hexagonal rod. Now the question is, why do we want to do that? There it is. You see, nothing to it. Well, why we want to do that is really rather simple. Okay, let's look at our hexagonal rod, and then let's go look at our hexagonal gear, our involute profile gear. Bingo. I've centered the rod on the center of the gear. Okay, see the rod goes all the way through. Now all you have to do then is Boolean model. Pardon me. You have to select the two objects and Boolean model. That just takes a moment. Okay, you can see the union of the two. Now you can select a union, an intersection, a first-second subtraction, or a second-first subtraction. If I remember correctly, a first section takes a chunk out of your hexagonal rod. A second-first removes the hexagonal, a shape the size of a hexagonal rod out of the middle of the gear. Okay, that's what you do. Now, what we're going to do then is we're going to hide those, and we'll show that already happening. Okay, that's what it looks like. Now, when you're going to print an object, this is what you do. This is what you have to have. You have to have the solid object. Okay? Then you go export it as an STL file. You crank it into what I call slice and dice software, which cuts, slices through it, and then traces paths for the printing of the plastic over those slices, and then you just print it. Okay? Now, milling an object, you have to do a little bit differently, because what you want to do is you don't want to print this part. You want to cut away everything but this part. So all of your machine movement is in the area either inside this object or around it. So there's a sneaky way that you can make that happen. Let's go ahead and hide that one, and let's go back and get our 12-toothed gear again. Okay, there's our gear without the hole in it. Now, what we have to do is to use a larger object to set that gear in. So what I've done is I've created a cylinder. Bingo. You see, and you set it in there, just like that. Then you go and you get your Boolean modeling again, and you remember, like I just didn't, to select both objects, the cylinder and the 12-toothed gear. Okay, now you can go get your Boolean modeling. Okay, now you can see what you got there, and let's see if we can't. There you go. And basically what you've done is you've cut the gear out of that cylinder. Okay? So let's go and get that. Let's hide this stuff. And let's go to, let's see if I can find that. Yes, here it is done. It takes a while to do that, and I'd already done them. Now, then you have to talk about the nut. That's real simple. You go back, you get your hexagonal rod. Bingo. Now you see there is a void that is in the shape of what you want to make, rather than a solid. Now we hide those, and you can then see the overall pattern for the thrust gear. Okay, That's how you do it. And then you go and you save that rascal as an STL file. Thank you.